Welcome to our case studies of major earthquake events in active mountain belts. We will explore 4 earthquakes, 2 large thrust events in China and Nepal, a complex multi-fault rupture in New Zealand, and a devastating blind thrust near Port-au-Prince in Haiti. For each case, we will visualize tectonic setting, surface rupture or broad deformation, earthquake-triggered landslides, and other ground failure, such as liquefaction. Finally, we will compare them side by side to see how tectonic setting controls geomorphic outcomes. First, the 2008 Wenchuan earthquake in China, magnitude 7.9, on the Longmen-Shan thrust system. It produced a 240-kilometer surface rupture. We sketched the mountain front and the thrust fault scarp with the hanging wall up. Surface displacements on the Beichuan fault were very large, up to about 9 meters vertical and 4 to 5 meters horizontal, a total slip around 10 meters. The defining geomorphic signature was catastrophic landsliding, tens of thousands of slides concentrated along the rupture, and especially on the hanging wall. Many landslide dams formed quake lakes that later had to be drained. Next, the 2015 Gorkha earthquake in Nepal, magnitude 7.8, a blind thrust on the main Himalayan thrust with no surface break. We show a buried fault as a dashed line under the surface and no scarp at the ground. The surface deformation was broad, uplift of about 1 meter near Kathmandu Basin and subsidence northward in the high Himalaya. We show this as up and down arrows. The quake triggered on the order of 25,000 landslides, fewer and generally smaller than in Wenchuan, with a tragic large rock ice avalanche at Langtang. Third, the 2016 Kaikoura earthquake in New Zealand, magnitude 7.8, famous for a cascading multi-fault rupture. We sketch strike slip and thrust faults with offsets and a prominent coastal uplift. The Kekarenga fault had up to about 10 meters of lateral offset. Roads and fences were jogged. The Papati block lifted the coast by several meters over more than 100 kilometers, creating new shore platforms overnight. The quake triggered around 30,000 landslides in steep graywacke terrain, strongly clustered near surface ruptures. Finally, the 2010 Haiti earthquake near Liagain, magnitude 7.0. It ruptured a blind thrust splay off the Enriquillo strike slip system with no surface break. We draw a buried fault and emphasize the lack of scarp. A major geomorphic impact was liquefaction and lateral spreading in Port-au-Prince harbor, causing wharf collapse. We show a quay tilting and sand boils. Landslides occurred, but were generally small and often along road cuts and urban ravines. Now, let us synthesize the 4 case studies. We will use compact cards to highlight mechanism, surface change, landslide signature, and other ground failure. Compare these patterns to see how tectonic style and environment shape geomorphic impact. Here are the key takeaways. Thrust earthquakes in steep ranges can couple uplift with catastrophic landsliding, as in Wenchuan, creating both tectonic and erosional pulses. Blind thrusts can produce subtle but broad surface deformation without a scarp, yet still trigger thousands of slides, as in Gorkha and Haiti. Complex multi-fault ruptures can localize landslides near surface breaks and reshape coasts dramatically, as in Kaikoura. Integrating satellite radar, optical imagery, and field mapping is essential to quantify slip, map landslides, and guide hazard mitigation. That concludes our comparative case studies. Use these patterns to anticipate geomorphic hazards in future earthquakes, where scarps, slides, and liquefaction are most likely.